I have already told you that it is a rational and practical design method, that is a limit state method. It gives a new approach of statistical probability. What do you mean by limit state? That limit state means an acceptable limit for safety and serviceability of the structure before failure occurs. So, this is called as a limit state, an acceptable limit for safety and serviceability of the structures before failure occurs. So, there is a concept of design with such limit state is to achieve the acceptable probabilities, so that structure will not become unfit for use and will not reach the limit state. So, though this structures or RCC elements can be designed to their ultimate loading conditions, they have added certain factor of safety that is called as a partial safety factor. So, once the structure which has been designed to their ultimate load, it start failing when it reaches, when the stresses in materials which reach their respective ultimate stress conditions, it starts failing. So, once in order to avoid that failure of structure, they have added certain factor of safety that is called as a partial safety factor. The partial safety factor, here it is, that is 1.5 for concrete and 1.15 for steel. This is called as partial safety factor. It is not like in the case of working stress method. Working stress method, the elements are designed to their working stress conditions. When they are not designed to their ultimate loading conditions, when you take the factor of safety, the factor of safety was found in the case of working stress method is 3 for concrete and 1.8 for. So, they have used huge amount of factor of safety, that is why this method failed. So, though the structures are safe after designing with the help of working stress method, this method will leads to uneconomical. So, this method, that is the limit state method, they design the structure to reach the stresses of the material to their ultimate loading conditions. In order to avoid the failure of the structures when it reaches the ultimate loading conditions, they are adding the factor of safety, that is called as partial safety factor. They are adding factor of safety partially, that is 1.5 for concrete and 1.8 for steel. So, in the case of limit state methods, there is a limit state means the acceptable limit for safety and serviceability of the structure before failure occurs. So, that is the concept of design with such a limit state to achieve an acceptable limit for safety and serviceability of the structures, so that the structure will not become unfit for use and will not reach the limit state. So, in the case of limit state design method, they have used two limit state, one is limit state of collapse and limit state of serviceability. That is, in the case of limit state method, they have added limit state of serviceability, that is a deflection and cracking effects were considered in the case of limit state method. So, here the statistical probability of strength and load can be estimated, which will be a limiting state of material in the case of limit state method, and the partial safety factor, that is I have already told you that the partial safety factor were introduced to reduce the probability of the failure to 0. That is in the case of limit state method. So, the advantages of limit state method over other method is, though this structure which is designed to their ultimate loading conditions, they have added some partial safety factor, that is 1.5 for concrete and 1.15 for steel. So, the structure will not be that is the probability of the failure of the structure in the case of limit state method will be reduced to 0. In addition to that, in the case of working stress method or in the case of ultimate load design method, the deflection and cracking effects were not considered, but here in the case of limit state method, the deflection and cracking were considered. These are all certain advantages and over the other two previous methods. Now, we are going to have a detailed look on working stress method. Before designing working stress method, we need to know what are the assumptions which are made in the case of working stress method. So, each and every method which has their own assumptions, and finally, they are checking that their assumptions are correct or not, and finally, they frame their assumptions. So, in the case of working stress method also they made certain assumptions. Using these assumptions only, the structures will be analyzed. Based on the analysis and the expression derived, they started designing the RCC elements. So, here the first assumption is, at any cross section, the plane section before bending and remain plane after bending. What does it mean? It means that the strain at any cross section of the beam is directly proportional to the neutral axis. This is something like it is based on the theory of simple bending. In the case of theory of simple bending, the layers above the neutral layers are subjected to compressive stresses and the layers below the neutral layers are subjected to tensile stresses. That is, in the case of neutral layers, there is neither compression nor tension. So, when we move towards the top, the stresses are gradually increased. When we move towards the bottom, that is from the neutral layer, it is gradually increased and reaches the maximum value. So, the strain at any cross section of the beam is directly proportional to the distance from the neutral axis. This is the meaning of the first assumption, that is, at any cross section, the plane section before bending remain plane after bending. The second assumption, all the tensile stresses are entirely taken care of by the reinforcement and none by the concrete except otherwise specifically permitted. This is a second assumption. So, here we all know that in the case of concrete, the concrete is very strong in compression, but weak in tension. So, in the case of a beam, when it is subject to any kind of force, if it is deformed, the layers above the neutral layers are subjected to compressive stresses. So, all the compressive stresses are entirely taken care of by concrete, since the concrete is very strong in compression. When you go the below the neutral, that is a portion below the neutral layer, all these things are subjected to tensile stresses. So, here the concrete is very strong in compression, but very weak in tension. So, that is why we have provided an alternative material to resist those tensile stresses, that is the material which is called as a steel reinforcement. So, here all the tensile stresses are entirely taken care of by the steel reinforcement and none by the concrete except otherwise specifically. In some places, the concretes are allowed to take certain tensile stresses, that is in the case of water tanks. In some conditions, in some structures only, the concretes will be allowed to take some tensile stresses. Next one, third assumptions, the stress strain relationship of steel and concrete under working load is a straight line. The stress strain relationship of steel and concrete is a straight line. This is a stress and this is a strain. That is, they are taking as a linear one. It is considered as a linear. Stress is directly proportional to the strain. So, that is why they have consider only up to this elastic limit, that is all. So, this is the point where the material reaches their maximum permissible value. So, that is why they have designed up to there. So, that is why the stress strain relationship of concrete and steel is under working load is considered as a straight line. Next, they have used, this is we have discussed already in the first schedule, that is modular ratio, that is a well known mechanics they have used in the case of working stress method. The modular ratio M is equal to 280 by 3 sigma CBC, where sigma CBC is compressive stress in concrete in bending, maximum compressive stress in concrete in bending. That is a bending stress, again the compressive stress, again it is called as a bending stress. So, where sigma CBC is a permissible compressive stress due to bending in concrete, which is represented in Newton per millimeter square, which is also given in table 21 of IS 456-2000. These are all the assumptions which is made in the case of working stress method. Based on these 4 assumptions, we are going to analyze and we are going to find out the expression to design the size of the section as well as the reinforcement required for it.